Hello. So what I intend to do with this series probably of videos is to answer this question, which is determine all real numbers alpha such that the floor of alpha plus the floor of 2 alpha and so on up to the floor of n alpha is a multiple of n for all natural numbers n. Now this is problem 1 in the International Maths Olympiads year 2024, and the idea for these videos is to slowly go through the problem, hopefully solve it, but just to demonstrate how someone who's not a professional mathematician might be able to attack these problems. It's inspired by Timothy Gowers' series of videos on the 2025 problems. I've seen one of those, and he attempts to sort of try to explain his thinking and use certain almost fixed techniques, generalization, using simple examples, things like this, for solving these problems. But I think it might be useful just to see someone like me who's not a professional mathematician attempt these problems, as opposed to a Fields medalist, and just see what the differences are and what things I am going to struggle with, and the ways in which the general techniques for solving a problem might be maybe misused, or the pitfalls that there are in trying to follow a sort of set of rules for solving problems. So let's have a look at this. I'm going to probably separate these videos out into about half an hour segments. And I've got a page here for rough work on the problem, and then just some observations. So here, first thing is, this is the problem. So it's determine all real numbers alpha such that this is this sum is a multiple of n for all n natural numbers. So I think one thing I'm going to do to start with, I'm just going to give this sum a name. So I'm going to say, let S of alpha be the sum in question. And then I'm probably going to give a name for, because we're looking for a subset of real numbers. Could be empty, but I'm going to give a name for that as well. So I'll just say let S be the set satisfying the condition above. Okay, so first sort of question is, can I think of any number, any real number that satisfies this? So first of all, maybe let's look at integers. Let's just look at, so actually, in fact, let's go to the rough work. So if alpha is equal to 1, then S of alpha is in fact, I'll just say, what's S of 1? I'm going to fix n. S of 1 is then the floor of 1 plus the floor of 2 times alpha, which is 2, plus all the way over to the floor of n, which is just the sum of this. So this is going to be n n plus 1 over 2. And that is an integer, of course. And that's an integer for all values. So it looks like, so 1 is then in our set S. It's not, sorry, it's not just is an integer, it's got to be a multiple of n. Now, is this a multiple of n for all n? Well, no, because for n even, sorry, for n odd, it would be. Because then n plus 1 over 2 would be an integer. But for n even, it's not. So that doesn't work. Doesn't work for n odd. So how about if we had so it looks like if we so it doesn't work for n odd, meaning it's not the case for all values of n. Now what about alpha 0? Well, if alpha is 0, all of them are 0, and so that is a multiple of n for all n. So S is non-empty. Since 0 is in S. Okay, well, can we get some positive value of alpha? So question 1. Is there an alpha greater than 0 in S? So let's just think about that. Well, I think let's try S equals 2. Alpha equals 2, so let's look at S2. Then we have alpha, floor of alpha, plus the floor of 2 alpha, which is 4, plus floor of n alpha, which is 2n. And that's then 2 times 1 plus up to n, which is n plus 1. And that is a multiple of n. So we have some positive value. 2 is in S. That's always a multiple of n, regardless of the value of n. So the answer, yes, 2 is in S. It sort of makes you think that all even integers will be in S. Is that the case? So let m be some integer, then s of 2m is going to be, well, floor of 2m plus 2 times floor of 2m, or floor of, it's not 2 times floor of 2m, but the floor of 2, the floor of 4m, plus floor of 6m, and so on up to floor of n times 2n, so 2m n. Now this is then 2m plus 4m plus dot 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 plus 2mn. You can take 2m out, we get 1 plus 2 plus 3 plus n. And then that's then equal to 2m and plus 1 over 2, which is m times n plus 1. Times n, sorry, which is a multiple of n. So we actually have infinitely many points in this set, at least. We've got contains a countable set. So yes, if you like, 2z is a subset of S. Now, are there any more points? Seems as though we sort of haven't really touched the number of points that could be in this set. So let's just, question 2. Is S bigger than 2z? So does it just contain the even integers? Or are there other things in that set? So one thing I'm just looking at is that for alpha to be in S, well, it must be a multiple of for n is what it has to be. So the floor of alpha has to be a multiple of 1. Okay, that's always true. let's go back to the. So we want to sort of think: are there other points that could be in? Are there any odd integers in there? So let's just let m be in z. Let's just try 2m plus 1. Well, this is an integer, so by the same sort of argument, we're going to get 2m plus, that's going to be 2m plus 1 times n plus 1 over 2. Now we have to show that this is a, so we need 2m plus 1 times n plus 1 to be even for all n in n. Now, obviously that is even for n is odd. Is it even for n is? So let's just check n. Let's just check some even value. So if n is 0, sorry, that's not a natural number. If n is 2, then this gives 3 times 2m plus 1, which is two odd numbers multiplied together, which is, so that's not, which is not even. So two m plus 1 is not in this set. So we know that no other integers are in S. Okay, so are there other non-integers in S? Just going to see how to clear this page. Yeah, so, and this is true whatever the value of m here. Yes, that's right. So we needed that to be an integer, meaning we needed that to be even. So let's just Let's do another. So let's just check for, just calculate S. Well, we've done S1, haven't we? So we don't need to do that again. Okay, so are there any other integers in S? No. So we've captured all the integers that could be in there. Are there any other reals in S? So let's just try something that is, and see what happens with the floor, because so far we haven't explored what happens with the floor function here. So I think I'm inclined to just check some value that's between 0 and 1. And half seems reasonable. Let's just try alpha is equal to half and see what happens there. So S of a half. And you've got the floor of a half plus the floor of 2 halves plus the floor of 3 halves dot 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 plus the floor of n halves. Now that is then 0. The floor of 2 halves is 1. Floor of 3 halves, so that 3 halves is 1 half, so that's 1. And then the floor will be 2. So then let's just say that'll be let's just suppose n is even for now. So then you've got the floor of then you've got plus n over 2 at the end, but the term before then would be the floor of n minus 1 halves, which would be the previous, so we'd only have one of those. So we'd get we'd get 2 lots of 1 plus dot 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 up to n minus 2 over 2, which is an integer because n is even, plus n over 2. And then, as if n is even, and then if n is odd, we just simply get 2 lots of 1 plus. That. Yep, okay. Now that what is this sum? So here then we have n over 2 plus 2 times n, so that's and then you've got n plus 1 divided by 2. And here you just have n plus 1. So then this top part, so that's n is odd. So then the top part here, which has 2 over 2. So you've got n minus 2 over 2 divided by plus 2 over 2. So it's going to be n over 2. You've got n over 2 plus n minus 2 over 2 times and here let's do it. So n plus 1 over 2. You've got n minus 1 over 2, n plus 1 over 2. Okay, so then we've basically got 1/4 n squared minus 1. Here we have 2 over 2 plus. Here we just have 1/4 n squared. Does that look right? Yeah, so take n over 2 out of that, you get 1 plus n minus 2 over 2, which is n halves minus 1 plus 1, which is n halves. So multiply that by n halves, you get this. Okay, now, when is this is this always going to be a multiple of n? Well, seems pretty clear not, because the bottom one here, well, if let's say n is 3, n is 1 works and it says 0. So let's just try n is 3 here, where then you're going to get 8 over, so that's 2. And 2 is not a multiple of 3. So this fails. And yeah, so I mean, is this a multiple of n? Well, it is when n over 4 is an integer. So it is when n is a multiple of 4. So basically not very many of these options are multiples of n. So we've concluded just that half is not in our set. So let's see, just write that down. Half is not in S. Now, I've tried integers, we've tried one rational number. I'm just wondering whether there's irrational numbers in here. But yeah, we'll save that until the next part, I think.